Today we're going to look at solving a system of equations by substitution. Substitution is the best way to solve this particular system because you have one equation that is in standard form, which is the top one, and then you have the bottom one, which is in slope-intercept form, with the equation already solved in terms of y equals negative 2x plus 18. Since we know that y equals negative 2x plus 18, we can substitute the value of y into this value of y, which will give us 7x minus 4 times negative 2x plus 18 equals 3. Now, we'll distribute across, so 7x plus 8x plus 18 equals 3. Collect like terms, that's 15x plus 18 equals 3. Subtract 18, so you get 15x equals negative 15. So divide both sides by, make that go away there. Divide both sides by 15. We get x is equal to negative 1. When we solve for a system and we get an x equals some number, that tells us that the system is going to have an x, y coordinates or x and y values. It means that the two lines that are here, 7x minus 4y equals 3 and y equals negative 2x plus 18, both will intersect. Now that we found what x is, we can turn around and substitute x into this bottom equation, and we can figure out what y is. So negative 2 times negative 1 plus 18. Y is 2 plus 18, so y is 20. So our answer is negative 1, 20. It's an ordered pair. If we were to graph these two equations, they would intersect at negative 1, 20. The next example that we're going to look at, again, this equation is in slope-intercept form and this equation is in standard form. When you have this combination, it's best to solve this system by substitution because we already have an equation solved in terms of one variable. So wherever we see y in the other equation, we're going to substitute negative 4x plus 6. So 12x plus 3 times negative 4x plus 6 is equal to negative 2. We will distribute 12x minus 12x plus 18 equals negative 2. Now, we're going to combine like terms. 12x minus 12x goes to 0. So our variables drop, which means that we have one of the two special cases when it comes to solving a system. We either have parallel lines or we have the same lines. We can tell by comparing what is left. Does 18 equal negative 2? It does not, so therefore the answer is no solution. So this particular system of equation, once we substituted the value of y into y in the other one, we came up with a situation where our variables dropped and left us with just numbers. And these numbers did not equal each other. The left side does not equal the right side, so therefore it is a no solution. Now let's look at another one. We have y equals negative 2x minus 6. This is in slope-intercept form, and the second equation is in standard form. With this type of scenario, it's best to solve this system of equations by substitution. So we've already got an equation solved in terms of one variable. So wherever we see y, we're going to substitute negative 2x minus 6. So in the other equation, here's our y. we're going to substitute all of that in for y. So we've got 4x plus 2 times negative 2x minus 6 equals negative 12. So we have 4x minus 4x minus 12 equals negative 12. 4x and negative 4x goes to 0. So our variables drop again. But now we're left with negative 12 equal to negative 12. Well, the left side now equals the right side. When you have this scenario, the answer is infinite solutions. Now, you can also have it called all real numbers, meaning any x value that you pick, it will work. Or any ordered pair that you choose will work. So, well, all right. So this concludes looking at solving a system by one equation that is slope-intercept form and one equation that is standard form.